Hey, what is going on everyone? I'm Wicked, welcome back to another awesome tutorial. Today we'll learn the difference between all types of tests as well as discussing why it is super important to test each and every line of code you write. Is it worth spending the extra time to write tests for our code? We'll find this answer to all of those questions soon. So without further ado, let's dive ourselves into the tutorial. Now, you need to realize that tests are not exactly something that you learn and understand the first day you get to see them. They might seem simple at first, but I can assure you that alone they are as detailed and complex as all of the chapters of Dart language we discussed up until now, if not even more abstract. In this tutorial, we'll only scratch the surface of tests, observing their massive importance, because this is essentially what you'll need to know at first. For now, let's start our long journey by looking at a package I specially created for this tutorial. Let me start by introducing you to the general idea behind this package. So, inside the lib folder, we have a library called geometry, a library that will contain multiple implementations of different geometric shapes. For now, it only contains a triangle shape. But in the future, you might imagine it may come packed with a square shape, a circle shape, rectangle shape, etc. As you know from the previous tutorial, these implementations represent separate libraries and they are placed inside the src folder. They are also exported by the barrel geometry.dart file representing the main library. Now, you might remember from college or high school that there are multiple ways we could describe a triangle. Of course, we could do it by specifying its 3 coordinates, but we can also describe it by specifying the length of its sides, or by mentioning the length of the base and the perpendicular height to it. There are many more ways we can describe it, but I've chosen those 3 for this tutorial. All fields are nullable since all fields are optional. A triangle that is only described by its length can have the rest of the fields set by default to null, or they can be all populated as extra fields. Now, due to all of these options we have into creating a triangle, I decided to code 3 named constructors, one for every case. Each triangle also has a triangle type field that will be set accordingly when created. Note that not every input you'll give will necessarily represent a triangle. For example, when the lengths are given, in order for them to denote a triangle, the triangle inequality states that the sum of the lengths of any 2 sides of a triangle must be greater than or equal to the length of the third side. This condition is verified right here. Obviously, lengths need to be positive numbers by default, so I also had to incorporate these conditions. Therefore, if a user inputs lengths of value 2, 4, and 1, the triangle isn't valid since 2 plus 1 is not greater than 4. So, there are conditions for every type of triangle we can create. Therefore, it makes sense to have a 4th triangle type called invalid that will be assigned automatically to the triangle of which some of these validation criteria are not met. Now, we're sure that no matter what the input of the user will be, our triangles will be either valid or invalid. So we'll proceed from here. Right now, it was the moment that I went ahead and started implementing the functionality of a triangle. I mean, yeah, sure, we managed to translate a triangle from paper into Dart. But what for if we cannot calculate its area, for example? Now, again, related to how we instantiated our triangle, there are multiple possible ways on how we can calculate its area. If the lengths are given, then it's this formula. If the points are given, then it's this sum divided by 2. If the base and height are given, well, we can calculate it directly by using this formula. But what is it going to happen if the triangle is invalid and we try to calculate its area? Well, we could return null or 0. But that would not be professional. Instead, we should throw an exception, and in order to throw a custom exception, we need to create one. So I went ahead and created a new folder called exceptions and named it invalid triangle exception. That's all. Now, whenever we call the area on a triangle type that's invalid, we'll throw this exception. So Now that we finished implementing this program, what's next? Well, we need to see by ourselves that it works as expected, right? Indeed, we'll go right ahead into the main file, instantiate some triangles, calculate their areas, then verify it with a calculator or another tool and see if they match, right? That's reasonable if you're only going to do this once. But let's analyze what is going to happen if you'll have to do this multiple times. And why would you want to do it multiple times? Well, there can be multiple reasons for that. You're working on a team, perhaps. Someone else modifies the code a little bit, perhaps to implement a new feature, pushes the changes to Git and creates a pull request. Then the next day you'll have to take a look over the entire code again, just like you'd implement it the second time. Or you'd create again some new examples, verify if the real areas match the one resulting from your program, and then perhaps accept the pull request to integrate the changes into the package. Or you could be working on your own, on another implementation that may interfere with the existing code. When you'll test the new implementation, you'll also have to retest the first one, hoping that nothing went wrong. You might see where I'm heading with this. This thinking is absolutely flawed, and you should get rid of it as soon as possible. Believe me, it's not rocket science. Imagine you had to write this program for a contest. You upload it to Git, and now the jury will clone all repositories to see how each of you did perform. Do you think that they will have to open your project, go into your main file, search for it, paste their own set of inputs by hand, import all the libraries, then run the program in order to compare the outcomes to the real result? Of course not. Instead, they'll have a set of predefined tests that they will loop to all submits. Run them all with those tests, compare the results, and rate the contestants accordingly. This will allow them to rate 100 contestants in a matter of seconds. Now think of how much it would have taken to do that manually, as I previously explained. This is exactly the difference between manually testing your implementations again and again every time you come up with a new feature, instead of writing tests that will glue and back up all your existing implementations all together, so that you'll only have to write tests for the new implementations. Let me put this into perspective for you. Here's a representation of the number of features you might want to implement in your app. There are two paths you can take from now on, paths that will seriously dictate your development workflow in the future. So let's design them one next to each other. You'll implement the first feature and you have to see if it works as expected. Student A will open the main file, create some examples, run the program, and note the results. Student B, on the other hand, will create automated tests. Think of all the possible cases where the program might fail, test them accordingly, so that in the end, the implemented feature is 100% accurate and fully working. Now, for the first feature, you might think that student A might complete the verifications faster, and that might be true in some cases. But let's think the other way around. The code he wrote inside the main file is more or less now useless. I mean, it kind of provides some assurance to the student that he did good, but from the app's perspective, it's completely useless. It doesn't bring any value to the game, and for me, what doesn't bring any value should be immediately omitted. It's like during an exam, you're writing all your thoughts and examples on the paper, hoping that you'll make your teacher give you more points for that. It doesn't really work like that. What the teacher cares about is that the result is equal to what was expected. Nothing more, nothing less. Your package should only contain stuff aiding towards the functionality of your app and not some random side notes. Student B, on the other hand, even though he might have spent more time writing all tests, doesn't have any extra unnecessary code in his project. Plus, he knows 100% that all his tests are correct and back up the entire functionality of the feature he just created. To me, this is priceless. It doesn't matter how many extra minutes I spend on writing tests. If those tests are automated and can guarantee that absolutely each and every line of code I wrote acts and behaves as expected, then I'll definitely go on with the student B approach. And take in mind we're only at the first implemented feature. What is it going to happen when we'll implement the second one, you might ask? Well, if the features are independent, then probably the exact thing that happened previously. However, when developing an app, there is a high probability that when you develop the second feature, some parts will interact with the first one, will depend on the first one, and perhaps will influence the first one. Well, student A will have to go back into the main file, undergo the same procedures as he did with the first feature, write some other tests for the second feature, as well as checking again if the first feature still works as it should. Student B, on the other hand, doesn't care about the first feature anymore, since it's 100% backed up by tests, so he only focuses on feature 2, and perhaps on all the interactions that may have with the first one. At the end, student A will have even more wasteful code, and student B will be more and more sure on himself that it's on the right track. Speeding up to the 10th feature, I can guarantee you that if you'll interview both students right now, student A will have a confidence level of around 20 to 30% regarding its app, since his way of verifying the functionality of all features will definitely decrease over time. The unnecessary code he wrote in the main file, let's be honest, won't look anything close to structured. It is going to become harder and harder to read and understand what's happening, not only inside the main file, but inside the entire app. On the other hand, student B will have a confidence level of around 90%, a value that is not only backed by the code coverage achieved by writing tests, but also by the cleanliness, the stable structure, the level of organization tests offer in his application. Having this said, it's up to you which student you'd like to be. I've been student A for a long time because this is what they're teaching us in school, unfortunately. However, noticing the advantages tests bring to the table, I need to admit I definitely changed my mind and perspective, and I advise you to do the same. Yes, tests might be harder to grab at first, but so is everything else in life. You'll eventually get used to it and laugh at the moments where you were testing the functionality of an app inside the main file. And speaking about how hard it can get to create things in life, this video is also an example of that. So if you find this tutorial useful and you appreciate the way I teach these concepts, please make sure to share the video, hit that like and subscribe button, and consider hitting the notification bell so that you'll know when I post a new video. Also, make sure to follow me on Twitter at Let's Get Wicked. This is where I'm at most of the time. Now, having this said, let's take a look at our package right now and delete this atrocity from inside our main file. Matter of fact, we can actually close the main file because we're not going to touch it anymore ever again. Haha, in Dart, ideally, in order to have 100% code coverage, that is to have a test for every line of code you write, you'll have to, well, clone your entire lib folder structure containing all implementations right inside the test folder, and then prepend the names of all your files with an underscore test. Every file you develop should have a test file in which we'll write the test suite, making sure the implementation works just as it should be. So, in my case, you can see I have a triangle underscore test.dart file in which I wrote all the tests I had in mind. The file is already getting pretty big, but so is the confidence level, highlighting that we have a stable and correct implementation of our triangle class. Now, what you need to know is that the tests you're seeing right here are all unit tests. Unit tests represent the easiest and most straightforward type of tests. They focus on verifying the smallest piece of testable software, such as a function, method, or class. As you might imagine, more than half of your tests will be unit tests, since, well, there will be a ton of functions, classes, methods, variables that you'll create, and all of those need to be properly tested. In my case, I need to test whether the triangle types were assigned properly depending on the variety of inputs users can provide to the program. As you can see, the entire test file is just a huge main function, ironically, in which you can declare multiple variables, set them up specifically to all possible use cases and scenarios, then enumerate all in separate tests. The main idea here is to think of every possible outcome of every variable, class, or method you implemented. For example, my triangle class could hold a triangle that is valid or invalid. and this is influenced by the inputs users can provide to my app. In order to write tests, the general idea you should follow is you should think of absolutely every possible scenario that will work, that won't work, and that may also crash your app. Therefore, I thought of the majority of those different valid and invalid cases, created a triangle for each and every case, and tested if the expected triangle type matches the right logical one. This was achieved by using the expect function, as you can see right here. The expect function thus takes two required positional arguments, the actual and the matcher, which kinda makes sense, right? The actual is your implementation that you want to test, whereas the matcher is the true result it needs to match. Note that each test has also a long description, a long title that it's 100% recommended to be as descriptive as possible, so that if a test fails in the future, you'll know exactly what needs to be checked out. You might have also noticed that the tests are surrounded in different groups. These do not play an important role in the standalone functionality of tests, but they make sure the tests look more organized, especially in the testing tab of VS Code. For example, in this section I'm testing if the triangle area is calculated correctly based on the triangle types, and then I've splitted all of the upcoming tests in whether the triangles are valid, in which I calculated the exact area with a calculator and checked if it matches the actual result returned by my area getter, and in those triangles that are of course invalid, in which I tested if indeed the getter throws an instance of invalid triangle exception. All of these tests can be run from terminal by typing in the dart test command, or by going into the testing tab and proceed from there by clicking this button. Either way, we have all tests ending up in green color, and that's perfect. That's the best thing you can see. All tests have passed. Now, apart from these tests, there are other types of tests like component or widget tests that basically verify that a component, which actually consists of multiple classes, behaves as expected. A component test often requires the use of mock objects that can mimic user actions, events, perform layout actions, and instantiate child components, for example, in Flutter. Mocking means that we don't actually have to press a button to verify that it does what it should. We can mock the action and let Flutter think that we actually pressed that button. Other types of tests we'll see in the future are integration and end-to-end tests. As their name implies, these verify the behavior of an entire app or a large chunk of an app. An integration test generally runs on a simulated or real device or on a browser in case of web, and consists of two pieces, the app itself and the test app that puts the app through its paces. An integration test often measures performance, so the test app generally runs on a different device or OS than the app being tested. Now, before I end this tutorial, I want to give you a little insight of the coding process and how I will proceed writing some other implementation for my triangle class, as well as how easy and straightforward it will be to test out the functionality. So, let's go right ahead and create a perimeter functionality. Whenever we call a perimeter getter, the perimeter of a triangle will be calculated and then returned by the getter. Note that we can only calculate the perimeter in two cases, when you have either the length of the sides or the coordinate points. In the second case, we can actually calculate the distance between the points, thus the length, by using this formula right here. So let's create another helper method called distance between two points and return the value denoted by this formula. Now, whenever we create a triangle from points, we can also initialize the A, B, and C side lengths by using the method we just created. The perimeter getter is even simpler to implement compared to the area one. All we have to do is to return the A plus B plus C parameter on the first two cases. If triangle is invalid, we'll throw an invalid triangle exception as well. However, if only the base and height is given for a triangle, we can't really calculate the perimeter out of that. So we'll have to create a new exception called unsolvable perimeter exception, which we'll throw in this specific case. Now, After we finished implementing the perimeter functionality, let's go inside the test section, and as you'll be able to see up next, not only we have already previous tests that make us more confident, but we can also use some of their structure as it's pretty similar in order to implement the rest of the test and use cases for the perimeter functionality. So you see, even though you spend some extra time writing tests, now you can even share some of their structure to create other tests, and believe me, the process will become faster and faster day by day, line by line. And I think it is finally time to end this tutorial on tests inside Dart language. I hope you finally found the motivation to switch from writing unorganized code to writing concise and truthful tests that will boost your confidence and development workflow in the long run. Don't believe me? At least give it a try by yourself once. You'll be really surprised by the outcome. For the next tutorial, we'll switch our view to yet other really advanced topics in Dart: synchronous and asynchronous workflows. We'll start with the synchronous one. It is going to be a really important topic to be understood, so make sure you have your mind ready to grasp all of the important concepts I'll teach you up next. As always, if you like this tutorial, don't forget to smash that like button, subscribe to my channel, and share the video with all of your friends and colleagues in pursuit of top tier development. Until next time, as always, take care, Wicked is out, bye bye.